Greetings, everybody. This is the second video for online lab number 7, conservation of energy for a mass on a spring. So now the first video explains how to get the spring constant, and so here I'm doing it for the small k, where remember you use a mass of 100 grams, release it from the equilibrium position of the spring, record using the simulation, get your XF, and then enter in the correct formula for the gravitational potential energy, then go ahead and solve for K. And now, okay, so now let's look at the small value. So for the and I got a K value. My K value is 3.92 newtons per meter. Don't just write that value down. Yours is going to be a little bit different than mine. Now for the small K, we're gonna so once we use the mass of 100, let me just backtrack a step. Once we use the mass of 100, that's just to get the K value. Then we're done with that particular mass. Then we're going to run the simulation for the first sheet, these values of the mass from 110 up to 180. And what you want to do is first you have to convert the masses to kilograms. Before I even worry about the simulation, let me convert them to kilograms. Well, actually, I'll do that last. So what I need to do is for each mass, I need to get the XF. So let me start with 110. Let me go back to the simulation. Let me go back. I'm at my small. Okay, I got my K value. Let me make sure no damping, 9.8. Just make sure all your ducks are in a row. We're at the small K value, which I know mine is the 3.92 newtons per meter, right? Now, so I want to do 110. Oops. Okay. Again, I'm going to go ahead, 110, put it on the spring. Make sure that the green arrow is 0. And then, now notice I've paused the simulation. That's a good thing though. See, I'm clearly at the equilibrium position. My mass is 110. I'm going to let it go. And I want to get XF. Okay. So I'm watching that green arrow. I'm going to go ahead and pause it when it gets to the lowest point. Okay, movable line just so I can get it pretty accurately. And it looks like I'm at 54 centimeters. So for 110, I've got an XF. Again, it's a little bit tedious, but I've got an XF of 54. Let me go ahead and type that in. Okay. Now let me do the same thing for 120. 130, etc. Let me go ahead and pause the video while I get the XF. I mean, you know how to do it. It's not rocket science. Now we go ahead, go back up to the equilibrium position, go ahead and make the mass 120. Okay, hit play, go ahead and get your XF. It looks like it's, oops, my finger got stuck there a little bit. So it looks like for 120, let me start over. Let me go for 120. Again, it's a little bit tedious. That looks good. 120, my XF is right there. I gotta go a little bit lower. Just a little bit more. Yeah, looks like I'm at 59.5. So this one, what did I say, 59.5. Now let me go ahead and pause this and get the rest. Okay, so now I've got my XF values for, I'm going to do the last one, 180. I'm going to go to simulation. What you want to do is, remember, for each mass, what you want to do is you don't want to change the masses while it's moving. So you want to pause for each time you change the mass. You want to go ahead, and it doesn't matter where. You can pause it right at the top. But you want to pause the simulation, take the old mass off, and then go up to here and go to the new mass. My last one is 180. Okay, then I'm going to take it, put it on the spring. Remember, I want to release it from equilibrium. See that green arrow? I want that to be non-existent. Right there. Perfect. Then hit play. Then when I think the green arrow is at the lowest, pause. Movable line. Take it down. Looks like I'm at 88.5. I'm almost at 89. Let me just make sure that I'm accurate. Let me see, the arrow comes down if it actually touches the movable line. And yup, perfect. So it looks like I'm at just about 89. Looks like, 88.5, 89. I don't know if it's going to matter that much. So let me just do 89. All right. So now I've got I did all my masses, did all my XFs. Now for sheets 2 and 3, notice I don't have the masses entered yet. You're gonna use different masses for the larger K values. Let's go back to sheet 1. Well, first I need to convert the mass to kilograms. Well, I just need to divide by 1,000. So I'm going to do in the mass column equals parentheses, and I want to do B15. See, it's highlighted, and I just want to do divided by 1,000 because that's kilograms to kilograms. Hit check. Okay, now in the E column, I need to convert XF. I need to convert XF to meters. So I click here in E15 and type in equals, and that's going to be D15. You see how D15 gets highlighted, divided by, in this case, 100. It's converting centimeters to meters. Hit check. Okay, perfect. Now, gravitational potential energy. Remember, the PE gravitational is mg. It's m times g times xf. So my PE gravitational is equal to dollar, not dollar sign. It's going to be C15. C15, that's my m, times. Now here's the dollar sign C, $5, because that never changes. Then that's my mg, and xf is D15, so times D15. Space, close parentheses. Hit check. Look at that. Okay, now let me just pause this for a second. I got a little bit careless. Right here for my PE gravitational, it's mg times xf. So the m is C15, that's my m. G is $C, $5 right there. And now xf, it's cell E15. I think I accidentally typed in a D. So that's my formula for the PE gravitational. Now notice the percent difference, I already typed in the formula for percent difference because that's very trivial. Now what about the spring potential energy? Well, remember that's 1/2 K XF squared. So we have to type in the formula. So equals, then left parenthesis, then another parenthesis, 1 divided by 2, that's my 1/2. See? Then times. Now my K value, that's not, K is in cell C12, so $C, $12, okay, because K is not going anywhere. Then times, well remember XF is the E column, E15, but it's XF squared, so it's going to be times 2 parentheses, left, E15, close 1 parenthesis, caret squared, close the other parenthesis, then I need one more, and everything. So that's 1/2 K XF squared. And hit check. And watch what happens to the percent difference. See that? 1.8349. Now, once you do that, to do the rest, I want to convert all the masses. Take that formula, hold down the left mouse button, copy it down. Here, convert XF, hold down left mouse, copy it down. That's the beauty of Excel. My PE gravitational, copy it down. Notice percent error, PE spring. Watch what happens to the percent errors when I get there. Ooh, shoot. Try this again. There we go. And notice very good percent errors, or percent differences, I should say. It's not a percent error, it's a percent difference. So that's sheet 1. Okay, so now again, once you type in the formulas once, remember all the cell references are the same, no matter if you're on sheet 2 or sheet 3. So I just have to copy and paste them into the correct location. Now the only thing is, for sheets 2 and 3, we're going to be using different mass values. Well, let me go ahead and save this video, and then I'll post one more explaining sheets 2 and 3. But this is what you're looking for. If your percent difference is probably under 2%, you're good. All right, let me save this video and get the last one posted.